All right, guys, 2019 free response number 3. So they've given you a function right here. This is the graph of f, not f prime or f double prime. We've got it's continuous. It's defined on this interval from -6 to 5. And then they tell you about the graph right here, what you probably would have assumed anyway, 2 line segments and then a quarter of a circle. And this is probably going to be important. It is known that the point 3 and then 3 minus the square root of 5 is on the graph of f. So they've given you the coordinates of that point right there. That'll be interesting at some point, I'm sure, but let's take a look at what's going on right here. Now, I did this problem in class with one class earlier today. A has a lot going on right here. So they've given you the value of one integral right here from -6 to 5. Now, -6 is not even on this graph. That's interesting right here. They want you to find the value of the integral from -6 to -2. Show the work that leads to your answer. Okay, so what is interesting is we have the graph right here from -2 to 5, but they're asking us, let me see, the bigger interval is this integral right here from -6 to 5. So I think I know where we're going with this, guys. So for part A, I think we're going to have to use the additivity property for adjacent integrals. I think we're going to need to say, okay, guys, the integral from -6 to 5 of this function, f of x dx, can be found by taking one integral that starts at the left endpoint, which is -6, and goes until this value that they gave us where the graph starts, which is at -2. That's our upper limit of integration in this integral right here. So from -6 to -2 of f of x dx, and then we'd have to add to that the definite integral from -2 ending at 5 now of f of x dx. Now, where are we going with this? This integral on the left, they told us the integral from -6 to 5 has a value of 7. So that goes right there. Equals, this is the integral we're trying to find the value of. So we don't know the value of the integral from -6 to -2 just yet, so we're fine leaving that one blank. But here's where a whole bunch of work has to happen now. We need to come up with the value of the definite integral from -2 to 5 of f of x. And we're going to get that information by looking at the graph and using an integral to find area. Okay, how are we going to do that? Well, the first thing I noticed right here is that if we start doing net area right here, this begins at -2, and we've got this little green triangle right here, but then almost right away, it flips to now being below the x-axis, and we get this red triangle right here. And what I'm hoping you guys notice, those two areas, one above the x-axis, one below the x-axis, just cancel each other out. So the integral from -2 to 0 is 0. I can kind of ignore that. Okay, what do we have next then? Looks like we now have, wait, nope, it's in red. There's another region that I kind of colored over right there, everybody, that we do have to consider right there. That's a triangular region below the x-axis. Its base right there is 1/2, and its height is 1. So 1/2 times 1/2 times 1 gives us an area there of 1/4. But since it's below the x-axis, it's going to be negative. All right, we've got that. Then, looks like we've got a positive triangular region that is right here. Okay, that one's above the x-axis. So the area of that region, let's take a look. The base down here is 3/2. The height is 3. So 3 times 3/2 would be 9/2, and then half of that would be 9/4. So the area of that green region is 9/4. And now the really fun part. I'm going to go purple with this one. We got to find the area of this region right over here. Now, how are we going to do that? We're going to notice, everybody, that we've got a square right here. And then the unshaded part of that square is a quarter circle. So if we were to take the area of the square minus the area of the quarter circle, that would get us the purple shaded area. So the area of the purple shaded region is going to be area of the square is 3 times 3, which is 9, minus the area of the quarter circle. So in that quarter circle, the radius is 3. The area of that entire circle then would be 9 pi. We just want a quarter of that, which is 9 pi over 4. Ugh, that's ugly. So that's what we have in purple right there. So now, for part A here, to come up with the value of that integral, we're going to add together this negative 1/4, this positive 9/4, and then this junk right over here. So the overall area then, guys, is going to be, let's take a look, negative 1/4 plus 9/4 is going to be 8/4, which is 2. And we'll add 2 to this value right here to get 11 minus 9 pi over 4. That's the net area now from -2 to 5 between this curve and the x-axis. And that is what we needed right here, guys. 11 minus 9 pi over 4. Ugh. Now, again, we switch back to red here. We're trying to find the value of this integral right here, which means I'm going to subtract 11 from both sides and add 9 pi over 4 on both sides as well. So, this is ugly. The integral from -6 to -2 of f of x with respect to x is equal to, gone, gotcha. The 7 minus 11 here is going to give us a -4, and that 9 pi over 4 doesn't combine with anything. So I'm going to write it as 9 pi over 4 minus 4. That is a pretty ugly answer, guys, but that is what they were looking for here for part A. All of that was worth 3 points there. So there's a lot going on just in part A. Okay, let's move on to part B. They want us to evaluate now an integral from 3 to 5 of 2f prime of x plus 4. So I better write that down here. All right, so for part B, a definite integral from 3 to 5 of, in parentheses now, it was 2f prime of x, close that off, plus 4, close that off, all taken with respect to x. Let me make sure I got that right. Yeah, f prime of x plus 4. Okay, got it. So what I think we're going to need to do here eventually is realize that we're taking an integral of f prime of x, which is probably going to take that back up to f of x then when we anti-differentiate that. And that information I think we can get from the graph. However, I don't think I don't think we're ready to do that just yet. So what I think we're going to have to do is show them that we understand some things about integrals. For starters, guys, an integral of a sum, this term plus this term, can be broken up into the sum of its two integrals. So my first integral then will be from 3 to 5, and it'll be of 2 f prime of x dx. But wait a minute, now I realize something. That 2 doesn't need to be there. We can pull it out in front. That'll give me what I want, I think, in that integral. And we'll add to that an integral from 3 to 5 of 4 with respect to x. And that I think we can evaluate straight up. So where are we here now, guys? We've got 2 here, and then let's take a look. We are doing an antiderivative of f prime of x, which is going to be f of x evaluated at 5 and then minus that at 3. So this is going to be regular f of 5 minus regular f of 3. So that's just showing them that we understand fundamental theorem of calc part 1, and that takes care of that. Then there's a property, guys, that says that if you're going to integrate a constant, I guess we don't need a formula right here. This becomes f of x, and there you go. But really, everybody, it's just going to be 4 multiplied by the quantity of 5 minus 3. That's what's going on here. So what do we have? 2 times, all right, f of 5. All right, I can read that right here, guys. F of 5 is a big old 0. And now I see why they felt the need to tell us in the directions the value of f of 3 right here, which is 3 minus root 5. Now we're subtracting it, so 3 minus root 5 needs to go in parentheses, and I need to distribute that negative inside there. And then what do we have here, guys? A plus 4 times 2 is going to get us an 8. Okay, so little bit ugly right here. This minus 3 becomes negative 3 times 2 out in front is a negative 6. That is a plus root 5 times 2. So that's a plus 2 root 5. And then a plus 8 at the end of all that is going to get us a 2 plus 2 root 5. And that's what I think we have right here for our answer for part B. Yep, 2 plus 2 root 5, and that's it. Okay, gotcha. What's going on in part C? G now is given by, and they've given you a function here, G is defined in terms of a definite integral of f of t. So let me write that down. G of x is equal to a definite integral from, it was from negative 2 to x of f of t dt. All right, f of t dt. Got it? And what's going on next? Find the absolute minimum value of g on the interval here from negative 2 to 5. So let's remember, guys, where can an absolute minimum occur? It can occur at endpoints and critical points. So we're going to have to check negative 2 and 5. Those are our endpoints, but our critical points come when our derivative is equal to 0. So we're going to need g prime of x. And a derivative of a definite integral with a lower limit that's a constant and an upper limit that's a variable. This is fundamental theorem of Calc part 2. This just becomes f of x. And we want to know, where is that derivative equal to 0? And that is going to happen, guys. F of x is equal to 0. Well, remember, oh, I've made a mess of this. Okay, remember, guys, this is the graph of f right here. So where does this function equal 0? Let me get rid of all of that. This thing equals 0 right there at negative 1, right here at 1/2, and then again at 5. So negative 1, 1/2, and 5. And where am I going here, guys? There you go. X equals negative 1, 1/2. We were already going to check 5 anyway, guys, because that was one of our endpoints. So these numbers here and these numbers here are all the spots where the absolute minimum value could occur. Now, it's an absolute minimum value of g. So we're taking all these values and putting them into the g function. Left endpoint of negative 2, first critical point of negative 1, second critical point of 1/2, and then the third critical point, which is also the right endpoint, so we're pulling double duty right there, of 5. So we're going to have to know all this information, and I'm taking all of these 4 values here, guys, and putting them back into this function for that x value right there. And the first one's nice and easy, negative 2. So a definite integral from negative 2 to another negative 2 is guaranteed to equal 0. Not too bad. Okay, the second one, the integral from negative 2 to negative 1 of this function right here. So from negative 2, this really should be green because it's above, to negative 1, we're talking about that region right over there. Area of that triangle is going to be a 1/2. Okay, so that's the value that we came up with right there for g of negative 1. Next one, g of 1/2. So if we're going now from negative 2 to 1/2, that means, let me go back red, these two regions right here once again cancel each other out, so just forget about them, and now we really just need the area of that region, which I had a few minutes ago and then I erased. That was 1/4, and it's below the x-axis, so that is going to be a negative 1/4. Oh, and the value of g of 5 is what I think I had before then as well. G of 5 would be the integral from negative 2 all the way to 5 here, guys, which we did right. Wait a minute. I had it right here. The integral from negative 2 to 5 was 11 minus 9 pi over 4. 11 minus 9 pi over 4. Got it. And here's where we're at now, guys. And we have to determine which of these 4 y values is the absolute minimum. Well, pretty clearly, since we have a negative value right here, it can't be 0 and it can't be 1/2. What I am concerned about is whether this value right here is positive or negative. And let's do just a little quick math. I'm just going to let pi be 3, everybody. 9 times 3 is 27. 27 divided by 4 is roughly, what, 6.75. It's definitely less than 7. So 11 minus that number, which is around 7, definitely has to be greater than 0. So it can't be this positive result either. So we would now say right here, guys, that the absolute minimum value of this function on this interval is negative 1/4. And that would be my answer then to part C. So a lot going on in that one right over there. Okay? All right. I'm just realizing now, hang on a second as I'm looking at it. Yep, I'm an idiot. Maximum value. Oops. Okay, Mr. Fontana, that's going to change this problem right here. Now, the good news is all the prep work is done, guys. However, now we'd have to consider which of those 4 values is the absolute, let's try it again here, buddy, maximum. So it's not the negative 1, and it's not going to be 0. It could be 1/2, but wait a minute, we just did this. We said that this value right here, again, was somewhere in the neighborhood of 6 or 7, which is greater than this 1/2. So nope, throw that one out. So let's try this again. The absolute maximum on that region right there is equal to this ugly value of 11 minus 9 pi over 4. Oops. Helps to read your directions carefully, everybody. Okay, and on to part D, which I looked at earlier today, and I was absolutely wrong about what I thought this problem was going to be. Almost, clearly not almost every time they ask you for a limit problem, or they ask you a limit question on a free response part of the test, it ends up being L'Hopital's rule. Now, in order to use L'Hopital's rule, you would have to show them that you tried direct substitution, plug and chug, and you ended up with one of the indeterminate forms that allows you to use L'Hopital's rule, usually 0 over 0 or infinity over infinity. So I said, okay, let's just plug this in, expecting fully to get 0 over 0. But let's see what happens here, guys. If we let x actually equal 1, 10 to the first power is 10, minus 3 times f prime of 1. Okay, let me go back to this graph right here, guys. And remember, this is the graph of f. So f prime of 1 would be the slope of the tangent to this curve right here at 1, which looks like it has a slope of 2. Gotcha. And right about now is when I started to realize earlier something was amiss. Pretty clearly, that numerator is not going to equal 0. Down on the bottom, here we go, f of x, which is f of 1. Now we actually want the y value at 1, and that's going to be a 1, minus, okay, arctangent of x. And I wonder if they didn't do this to trick you guys. If it weren't for the arc, if it was tangent, no, that's not what they were doing. Okay, anyway, arctangent of x. Guys, if you're not familiar with that arctangent, it's kind of an older way of writing inverse tangent. So inverse tangent of 1 is asking you what angle on the right-hand side of the unit circle has a tangent value equal to 1. That happens right there at pi over 4. So what happens, guys? The numerator is 10 minus 6, which is 4, and the denominator, okay, now here's a good lesson to learn right here as I'm looking at their solutions manual. The denominator is kind of ugly, but I want to remind you guys that according to what they say and what they tell me to tell you guys, you don't have to simplify your answers. You can leave this in the ugly form of 1 minus pi over 4, and in fact, that is exactly what they have written down for their answer here in the solutions manual, 4 over 1 minus pi over 4. Okay, so there's part D just kind of crammed in. So I was surprised. I thought for sure part D was going to be a L'Hopital's rule question, but it didn't work out that way. So there you go. That's part D. All right, guys, that's a wrap on number 3.